Good evening, everyone. Welcome to this week 10 discussion for this course, Computer Vision. And this course is originally taken by Professor Jayanta Mukhopadhyay, Professor, Computer Science and Engineering Department of IIT Kharagpur. Myself, Ayan Paul. I am a PMRF Research Scholar from IIT Kharagpur and I am a PMRF TA of this course. My duties are I will solve some of the question that will be very much similar to your assignments, so that whenever you will be solving your assignments you will not feel it's completely new. Okay, so let's start the discussion. So today we will be discussing something regarding classification and clustering. Okay, so first of all, what is classification and what is clustering? So clustering is the primary task and then we move to classification. Okay, so what is clustering first? So just 1 minute. Yeah, so what is clustering first? So this is clustering. You can see in the image. So you can see these are mushroom. Okay, these are mushroom. But in clustering, what we do, clustering is the task of organizing object in the groups whose members are similar in some way. So just we are given a variety of things and we are just clustering or grouping it based on the similarity. We do not know the label of that product, but we are just uh, we are just grouping together based on the similarity. So that is clustering. Okay, so clustering is a cluster. What is cluster? So after clustering is nothing but to group it into members, to group the object into similar to group the similar object which are similar in such some way. Okay, so this is clustering. So what is a cluster? A collection of object similar to each other but dissimilar to the object belonging to the other cluster. So that is cluster. So again I am repeating, clustering is the task of organizing objects into groups whose members are similar in some way. Okay, so just for example, you are given so many different fruits. Okay, and you are told to cluster it. Okay, so what you will do, you will group similar fruits into fruits into one group and dissimilar fruits into other groups. Okay, so that is clustering. So reasons of homogeneity in an image, so that you can do. So clustering, what we do, we just segment the homogeneity or segment the similar things into one group and segment the dissimilar things into other group. So that is known as clustering. Okay, so another thing is known as classification. Now classification and clustering are very much similar to each other and there might be a lot of confusion, like what is clustering and what is classification. Now same example that I have given you, regarding you have given so many types of fruits. Now the difference between clustering and classification is, whenever you are doing classification you are clustering first, but then you are labeling the fruits into a common label. Like in clustering you are just separating the fruits into different groups. Okay, like you are seeing some red color rounded objects or spherical fruits, so you are clustering in one group. You are clustering a yellow color fruit, and then you are clustering in second group, like that. But you are not giving any labels whenever you are talking about clustering. But in classification, what is the difference? Classification, you are giving labels to the cluster, like the red color fruits that you have clustered. Now you will label it like this is an apple. Okay, and then the yellow color fruits that you have clustered it, now you will label like this is a banana. Okay, so that is the difference between clustering and classification. So clustering is just grouping, classification is grouping with label added. Okay, so that is known as clustering and classification. What is a cluster? Now cluster, a group with loosely defined similarity among the objects. Cluster has the potential to form a class. But whenever we talk about class, a class is a well-studied group of objects identified by their common properties and characteristics. So I am just summarizing again what is clustering and classification. So you are given a basket. Okay, and then you have told to cluster it. Now what you will do, you will pull the similar type of fruits. What you are seeing, just seeing like red color fruits, you will cluster in one group. the yellow color fruits you will cluster in another group, like that. So that is clustering. So you are grouping it, but the group is very loose, okay. But whenever you are talking about classification, you are grouping it, but give label to the group, like the red color fruits, that are apple, like the yellow color fruits, that is a banana group, okay. So that is the difference between clustering and classification. Here the group is loosely defined. Now in classification the group is well defined. So that is the difference between clustering and classification, okay. Clustering, what is the motivation? Finding representative for homogeneous group. So always we try to form group based on the homogeneity, like the objects which are very similar or in a way homogeneous to each other, we generally group it, okay. And second, to discover natural groups or category, yeah. And then finding relevant groups and detecting unusual data object, that is very important. Like in a fruit basket, there may be some due to some thing, there may be some impurity or some wrappers, etc., okay. So that we will not consider as a similar object. So if we can cluster our fruits or cluster the similar things, so what we will do, we'll cluster only fruits and we will leave the other things behind. So that is the motivation of clustering. Now this is the processing pipeline for either classification or clustering. First we take the input image, then we do the pre-processing step. Pre-processing means before applying any algorithm, we have to pre-process the image, like size the image, or sometimes we do this augmentation step where we have small number of images. So to increase the number, we just apply different augmentation steps like flipping, etc., to increase the number of images. So that is pre-processing. And then we do the feature extraction that we have already learned, because with feature extraction only we can say which are the among the two groups or among the two objects, either they are similar or not, okay. So for that we have to do feature extraction and then feature matching. And after that, when the process is complete, after the process is complete, this clustering is occurred. And if you want classification, you have to provide labels to it, okay. So that is clustering and classification, okay. So this is regarding clustering and classification. Second is types of learning. So you may have heard these terms again and again. One is the supervised learning, another one is this unsupervised learning, and third important one is this reinforced learning. Okay, so what is supervised learning? Supervised learning means exploit knowledge about the classification problem, such as instances or classes, okay. So supervised learning means you have presence of any prior knowledge of that group, okay. So that is supervised learning. For example, a teacher is first teaching you some subjects, okay, and then he is taking your test. So that is supervised learning. But unsupervised learning means you are just going to the first day to any class and the teacher is asking some random question without teaching you. So that is unsupervised learning. So these are the two main types of learning. Now classification, you remember in classification we are giving labels to the object. So classification is a type of supervised learning, whereas clustering, where we are doing the grouping loosely, so that is a unsupervised learning, because we do not have prior knowledge. We cannot label the group. We can say that these are yellow color fruits, these are this red color fruits, but we cannot give labels to that image because we do not know anything. We do not know that this red color fruits are called apple, or this yellow color fruits are called banana. So that we do not know. So that is why clustering is your unsupervised learning. But classification, as you are giving labels to the object, so that means you already know these objects priorly, okay. Then only you can say, na, this red color fruit is actually apple, or this yellow color fruit is actually banana, okay. Then only you can do. So that is why this classification problem is a type of this supervised learning. And then we have a third category known as reinforcement learning. This is a new type of learning. So reinforcement learning is the best example is cycling, okay. So reinforcement learning by feedback from a teacher or a critic in the form of reward or punishment, okay. So that is reinforcement learning. So reinforcement learning means neither supervised nor unsupervised, Okay, reinforcement learning means it is based on reward and punishment. Okay, for example, whenever you are cycling it, okay, so you do not have prior knowledge, so you can say it is a unsupervised learning, but then unsupervised learning is very loose. Okay, so that is not. And here how you are learning cycle, whenever you are learning cycle, you are peddling it and you are trying to do those things which by which you should not fall. Okay, if you are falling by that thing, you will never do it again. Okay, so that is reinforcement learning, means if you are not falling, so you are giving yourself reward and you are mastering that the way you are cycling. If you are following it by certain means, for example, for example, some your direction is not well, or you are making shaft, then for that you are falling, so next time you will not do that. So this learning is based on reward and punishment, so that is why it is known as reinforcement learning. Okay, now we will start the clustering. So clustering, there are three major components. Option A, or the first thing is similarity distance measure between the two data samples that we have already discussed, L1 norm, L2 norm and LP norm. We have already discussed in the previous classes. Okay, so this is nothing but type of measuring distance. Okay, so that is L1 norm, L2 norm and LP norm. L2 norm is the most common. L2 norm is also known as Euclidean distance. Okay, so that is the most common. That is d1 or the distance between like x1 and x2, or point x1, capital X1 and x2, that will be given by root over x2 minus x1 square plus y2 minus y1 square. Okay, so that is known as L2 norm or the Euclidean distance. That is the most common thing. And then criteria function to evaluate cluster. Now once the cluster has been formed, you have to evaluate that this cluster are it is a good cluster or bad cluster. So how you will do? You will do by your intra-cluster cohesion or inter-cluster separation. Okay, so what is the thing? In the same cluster, you want your members to be very nearer to each other, and in different cluster, you want the member to be as far as each other. So intra-cluster cohesion means within the cluster, your members should be very close to each other. And inter-cluster separation means if we compare two members in two different clusters, the member should be as much distance. The member should be as much separated or more distance to each other. So this is the thing. Now intra-cluster cohesion we measure by this sum of square error. That is nothing but from the center distance to your member. Okay, so that should be as less as possible. So if that is as less as possible, means the points are very much closer to the center and your intra-cluster cohesion is more. So this is the criteria, second criteria. And third is the clustering algorithm. We have this different clustering algorithm, K-means, K-Medoid and mixture of Gaussian, that we will just be discussing. Okay, and regarding this intra-cluster cohesion and inter-cluster separation, this is the thing. Cluster cohesion is also known as homogeneity. Okay, so homogeneity means elements within the cluster are close to each other. Okay, so you can see in this image like this is a bad clustering. Why this is a bad clustering? Because here you can see the homogeneity is very less, means the members in this, we have two cluster. This is the first cluster, that is the red cluster, and this is the second cluster, that is the green cluster. You can clearly see that this members in the red cluster is very much separated with each other, but very much separated to each other, and also the members in the green cluster are very much separated to each other within the red cluster and green cluster respectively. But this is an example of good clustering. Why? Because the member in the same cluster are very much are closer to each other, and members in the green cluster are closer to each other. Okay, so this is the first criteria. Second is the separation or the inter-cluster separation. Okay, so that is elements in the different cluster are farther apart from each other. Okay, so you can see this is a bad cluster because element in the different cluster are very much closer to each other. Okay, but they are very much far away from each other within the same cluster. So here homogeneity is less and separation is more. So that homogeneity is less and separation is also less. So that is why this is a bad clustering. But here you can see the homogeneity is also more, and separation is also large, like this and this is a more separation. Okay, so that is inter-cluster separation. Okay, so two concept, homogeneity and separation. Okay, so this is the thing. Then we will be starting our k-means clustering. So up to this, is it clear? Shrujana, is it clear up to this? Difference between clustering, classification. Are you there? Okay, no problem. Okay, and yeah, so this is the basics between clustering, classification, etc. Okay, and now we will be moving into clustering algorithm. So first is your k-means clustering. Okay, so k-means, k is nothing but k is the number of cluster. Okay, and means is mean, you know, mean or average. Okay, average you all know, like you have 5 data points, you can do the average. Okay, so that is the same thing. So k-means comprises of two words. K means number of, k is the number of cluster, or k-means means there will be k clusters, and means average. Okay, so that, by this two we have this algorithm k-mean clustering. Okay, so k-mean clustering partitions n points xi from I equals to n into k cluster. Okay, so that what I have told, means clustering means k cluster, so that the sum of squared Euclidean distance from the point to the cluster centroid. Okay, here the cluster centroid is made by means. Okay, so k means k cluster, and cluster centroid is nothing but the mean of the cluster. So that is k means. Each cluster centroid is the arithmetic mean of the points. So that is why k means. K mean clustering. Okay, so this is nothing but, this is known as cost or objective function. So this we need to minimize. So now what is in this objective function? In this objective function, xi is nothing but any point. Okay, any ith point, xi from I to n, so any ith point. Mu k is the center of the particular cluster. Okay, and this xi minus mu k square, this is nothing but you can say your distance only, the square of distance. Okay, because root we are not our. So someone is joining. Yeah. So this is the objective function. So xi minus mu k whole square, and then we have to do it for all the points, and we have to do it for all the cluster from k equals to 1 to k. So this is the objective function. This we need to minimize to make a good cluster, or to perform this clustering. This we have to perform. This should be as less as possible to make a good cluster. Okay, so this is the k-means algorithm. Core formulas I have already told you, like you have to, yeah, so I will just explain it by an example that will be more clear. And update centroid, how we should update the centroid. For one cluster, what you have to do, you have to take the mean of all the points. So by that you can update the centroid. So that is k-mean clustering. So again I am repeating, k-mean clustering, it comprises of two things. One is k and another one is mean. K means k is the number of clusters, that is k cluster, and means cluster center will be nothing but the arithmetic mean of the point. So that is why k-mean clustering. Now let's this is nothing but all the steps, so I will just explain it with an example that will be more clear to you. So we have this 6 data point. Okay, p1 is 1 comma 1, p2 is 1 comma 2, and similarly p6 is 8 comma 6. So we have this 6 data point. Now it has been told set k equals to 2, that means we have 2 clusters. Okay, 2 clusters. Initial centroid is given, mu1 is given. This is the initial centroid, that means initially the centroid you should consider this, that is mu1 is given, that is 1 comma 1, and mu2 is given 6 comma 5. Perform 2 iteration of k-means, show formulas assignments, that is using squared Euclidean distances, and centroid update, that we have to do. Okay, so key formula I have already told you, we have to compute this j, that is the objective function. We have to assign each point to a center based on the minimum distance. and then we have to update the centroid. Okay, and this is the formula of Euclidean distance that I have already told you. That is nothing but, you all know, x2 minus x1 square plus y2 minus y1 square, and here as we are taking square of Euclidean distance, so that is why d square will not have any square root. So these are the key formulas. So iteration 1, how we start the iteration 1. So we already, the center of the initial center or initial centroid are given for the cluster. So initial centroid for cluster 1 is given this, that is mu1, and initial centroid for cluster 2 is given this. Okay, now what our second step is to compute square distance and assign each point to a particular cluster. Okay, so first how we should assign each point to a particular cluster, we have to compute this, that is distance square of P1 and mu1. Okay, P1 is the point and mu1 is the first centroid. Okay, similarly you have to compute distance square of P1 and mu2. P1 is the point and mu2 is the second centroid. Okay, so then you have to compare which is smaller. So here this distance of P1 U1 is 0 and distance square of P1 U1 is P1 U2 is 41. So P1 is more closer to which center? P1 is more closer to U1 center. So we will assign P1 to C1. Similarly, we will perform for P2, P3, P4, P5, P6. Okay. So according to the distance, here you can see, for example, let's take P5. Okay. So P5, for this distance P5 from mu1, that is coming 72, whereas P5 to mu2, that is coming only 5. So P5 is closer to C2. So we will assign P5 to C2. So now this is the assignment. For this cluster C1, P1, P2 and P3 are the points. For this cluster C2, P4, P5 and P6 are the points. So this is our first iteration clusters. Okay. So our first iteration clustering is over. Now what we will do, we will update the centroid. How we will update the centroid? For C1 we will take this 3 points and we will take the mean of it. Okay. So just take this 3 point. P1 is how much? P1 is 1, 1, P2 is 1, 2 and P3 is 2, 1. And then just take the average. Average is nothing because we are dealing with 3 points, so divide by 3. So our first centroid update is this and second centroid update is this. So this is regarding the updated centroid in iteration 1. Now for iteration 2, we have this initial centroid, that is the updated centroid in the previous step, and then again we will calculate all this, that is this. Now here you can again see all the P1, P2 and P3 and P4, P5 and P6, P1, P2 and P3 are coming to C1 cluster and P4, P5 and P6 coming to C2 cluster. That means we have not any change in we will not have any change in this cluster. Only our centroid will be changing. This is the again our centroid will also not change because the points are same. Like previous iteration, our points are coming same. For each cluster we are getting the same point. So this is the finals after 2 iteration. This is for cluster 1 and this is for cluster 2. Okay, so algorithm has stabilized by iteration 2 and membership function will not be changed. Okay, so this is how you will perform the k-means clustering. Okay, so any doubt regarding this, how we have performed the k-means clustering? Any doubt in any step, you can please ask. Dhatri, any doubt? Or Shujana, any doubt? Any doubt you can ask, no problem. Simple to simple doubt, no problem. Okay, nice. Now let's move on to the next thing, that is K-Medoid. Okay, now K-Medoid, again K-means and K-Medoid are very much similar. Only one difference, K means the number of cluster, K is the K cluster. Now the centroid, earlier the centroid is determined by the mean or average. Now the centroid will be determined by the median, not the mean but the median. Okay, so that is the difference between K-means and K-median or K-Medoid algorithm. So unlike K-means, Medoids are actual observation robust to outlier. So what was the problem in k-means? Whenever we are calculating the updated center, you can see over this question, when we calculated the updated centers here, you can easily see. Now when we calculated the updated centroid, this centroid are not the points in the data. So this can be outliers, right? So that we do not want. So we want the updated centroid to be within the data. For that we have converted from k-means to K-Medoid. K-Medoid is also known as the span or the partitioning and around medoid. Okay, so same thing, just the name has been, this is the next or another name for this K-Medoid algorithm. So again I am repeating, very similar to K-mean algorithm, only during update center, what we will do regarding updating the centroid, we will update the centroid based on median, not the mean, because median is an actual data point that belong to the group, but that belong to the data, but mean can be a data point that does not belong to the group. So that was the problem. So to deal with the problem, we changed from k-means to k-medoid. Other things are very much similar. Okay, now you can see this question, again same thing, again first step we will these are the same points. Okay, here the medoids have been given, or the first centroid has been given. Here again it has been told k equals to 2, you have to do the calculation. That means we have 2 clusters. Okay, again first step you will do the same thing, that is calculate the distances and which the points which are closer to which center, you will assign that point to that cluster. Okay, so first step is same, second step is also same, just you have to do the clustering. After that what you have to do, when you are updating it, okay, when you are updating it, what you need to do, like now the when you are updating the medoid, okay, where the update has been done, yeah, here the update has been done. So before, the cost calculation has been done. Okay, so cost calculation is nothing but the distance of the all the points, like distance of p1 m1, p2 m2 and p3 m1. Okay, and then distance of all the points to the respective cluster center. Okay, so that is coming for this c1 center, that is coming 2, and for the c2 center, that is coming 4.48. so total your cost is coming 6.48. This cost, our idea is this cost should remain the same in the next iteration, or this cost should decrease. Okay, that is our idea. Okay, so for that what we will do, again we will update the centroid. How we will update the centroid? We will update the centroid by changing the medoid. Okay, or changing the median. Okay, so how we will do for c1 candidate p2 or p3, if p2 as medoid, the distance is coming this. Okay, and if distance is coming 2.41, that is worse than 2. P3 as medoid, the distance is coming 2.41. Okay, so definitely we will not change the m1. Okay, that is the this centroid we will not change. But when we are talking about candidate 2, if p5 as a medoid, the distance is coming this 1.41, 1.41 and 2.43, that means total it is coming 4.24. okay, that is better than this 6.48. okay, and also if p6 as medoid, the distance is coming c, so we can take either p5 or p6 as the new medoid. So now we have taken p5. Now what is the change? When we just took p5, you can see our cost is lower than before. Our cost is coming 6.24. Earlier it was 6.48. Now the cost is coming 6.24. So we have done the improvement. So again we can just check it, and again we can change the medoid so that our cost comes more or less than that. Okay, so that is how we can do the k-medoid calculation. Okay, so this is regarding k-mean and k-medoid. So very easy. Just if I just simply tell you, there are two algorithms. One is k-means, one is k-medoid. K-means k, the meaning of k is number of cluster in both k-means and k-medoid. In k-means, we do the check the centroid of the cluster based on average or the mean of all the points belonging to the cluster. In k-medoid, we take the centroid of the cluster as the median point of of the points belonging to that cluster. So that is the difference between k-means and k-medoid. Okay, so that is the only k-medoid is also known as spam or partitioning around the medoid. So that is the main difference. And second thing, why we move from k-means to k-medoid, because k-means, when we are calculating the centroid in k-means, what happens is the value that we are getting, that is not an actual data point. But in k-medoid, whenever we are taking the median of the data points, the median always belong to the data points. Okay, so that is why we changed from k-means to k-medoid. Okay, other things are same in k-means and k-medoid. Okay, so this is the thing. Now we have this third thing, or the third clustering algorithm, known as this mixture of Gaussian, or the GMM. Okay, so a GMM model has three important parameters. One is, GMM means Gaussian. You all know what is a Gaussian. Gaussian means this is a Gaussian distribution. So Gaussian will have this one peak and the data like this. Okay, or the bell curve. This is also known as bell curve. Okay, so most of all the curves, like if you just do a survey and find out height of all the person or the weight of all the person, all these curves will come Gaussian. Okay, so that is known as Gaussian distribution. Now we have this algorithm for clustering known as mixture of Gaussian, or GMM. So this mixture of Gaussian, for this the probability is calculated like this. This is how we calculate the probability. Here k again means the number of cluster. Okay, now we have this three important parameter. One is pi k, or the mixing coefficient. Now this k-means or k-medoid algorithm, these are hard clustering. What is hard clustering? Hard clustering means the cluster do not overlap each other. So that is hard clustering. Okay, H. Okay, and this Gaussian mixture is an example of soft clustering. Soft clustering means this cluster can overlap each other. Okay, so this Gaussian mixture model is a example, or is an example of this soft clustering. Okay, now this for this Gaussian mixture model, we have this three important parameter. One is this pi k, or the mixing coefficient, that will be for each cluster. Okay, k means subscript k means the cluster, means pi 1 means mixing weight of number 1 cluster, and pi 2 means mixing weight of number 2 cluster. So that is pi k. Pi k means mixing weight. And then we have this mean for each mu k means mu 1 means like mean of this first cluster, and then we have this covariance, or sigma k means covariance of the first cluster. Okay, so these are the three important parameter for the mixture of Gaussian model. Now here we do the update. Okay, let me just erase it. Okay, so here how we do the update? We do the update by this algorithm, that is expectation maximization, or the EM algorithm. So first we have this E step, or the expectation step. In expectation step, we calculate the responsibility or the likelihood. In the M step, we try to maximize. We have this three parameter, pi k, mu k, and sigma k. We try to change this parameter or update this parameter. This mu k will be changed like this nk will be changed like this, and this pi k will be changed or updated like this. These three things will get updated, and by that our responsibility or pi this gamma ik will increase. So that is together known as EM algorithm, or the expectation maximization algorithm. Okay, this will do for increasing the likelihood. Okay, this first step is known as expectation or likelihood. So this M step, or the maximization step, we are doing to increase this likelihood. So that is why together it is known as expectation maximization, or the EM algorithm. Okay, so these are the two steps. Now here also I have given a question, but definitely this is a very big question, and I will not discuss it, but this is the way. Okay, again I am just giving you the theory. So if you just understand the theory, you can do the question. Here same thing has been done. First the likelihood has been completed at L0, and then what has been done, this mu1 and sigma 1, or this variance, and pi1 has been changed to get the L1, and then in the next step also this pi1 has been changed to this yeah, there are two clusters, so there will be two things, that is mu1 and mu2. So this is for this first iteration, this is your updated mu1, mu2, sigma 1, sigma 2, and pi1 and pi2 values. Similarly, this is for second iteration, this is your updated value, this is your updated, where is the updated value, yeah, this is your updated value, mu1, mu2, sigma 1, sigma 2, and pi1 and pi2. Okay, now this is the L2, or the likelihood in the second iteration. So you can clearly see that L1, L0, or the likelihood in the 0th iteration is coming this, the likelihood in the second iteration is coming this, and likelihood in the third iteration is coming this. That means likelihood is increasing when we change the parameter pi1, mu1, and sigma 1, or pi2, mu2, and sigma 2. Okay, so this is the this is known as EM algorithm for this EM algorithm, or expectation maximization algorithm for this GMM clustering. Okay, so this is how we have done. Again, I am telling, like L0, or this likelihood at the 0 step is minus 9 point something, then likelihood at the first step is minus 3 point something, so likelihood is increasing, and likelihood in the second iteration is minus 3.56. so again from minus 3.67 to minus 3.56. so again likelihood is increasing when we are changing the value of pi1, mu1, and sigma 1. so that is how we just put the EM algorithm for this GMM clustering. Okay, so this is how these are the three clustering that we have discussed. One is the K-means, K-Medoid, and third is the GMM clustering. And for GMM clustering, we have this algorithm known as EM algorithm, or expectation maximization algorithm. Okay, so this is regarding clustering. Now if you are more interested to read more about clustering, you can just open this 2 slide. I have more details regarding clustering. So as I have told, like clustering, there are two type of clustering. One is hard clustering and soft clustering. Okay, another is regarding this hard clustering also, we have this different types of clustering, like the K-means and K-Medoid. These are nothing but distance based clustering, but there is also known as hierarchical based clustering and density based clustering, that you can check by these two links if you are interested. Otherwise, these three algorithms are in your this course. Okay, so this is regarding clustering is completed by this slide. Okay, so any doubt regarding this clustering, any part, any doubt, you can please ask. Any doubt in clustering? Okay, so I assume no doubt. And then we will move to this next thing known as classification. Okay, so classification we already have discussed the definition, that this task of assigning a known category or class to an object. Okay, here it is here there are different type, again there are different type of classification. So first, regarding this probabilistic mode of classification, so Bayesian classification is a type. Then this distance based mode of classification, we have this KNN classification, or K nearest neighbor for this method. And third, we have this discriminant analysis, and for that we have this LDA, or linear discriminant analysis. And fourth, we have this artificial neural network. Okay, and for that we have this feedforward neural network. So these are the 4 different classification that has been discussed in this course. Okay, so regarding this Bayesian classification, it used the Bayes theorem to compute the posterior probability of each class given the observed feature, and then chooses the class that maximize the posterior. Okay, so let's just discuss this with formula. You will get so many data points. For each data point, you can easily calculate the px. Okay, or px is nothing but probability of the data point. Okay, so that is px. So px you can easily calculate. You can also calculate the pck, that is probability of each class. Okay, that also you can calculate. What next you can calculate? You can also calculate the prior probability. Okay, this is known as prior probability. Prior probability is also very easy. Prior probability, or yeah. So PCK is known as prior probability. PXCK is this likelihood or the class conditional probability. That also you can easily calculate. How you can calculate? So for each class you can see the number of data points, so according to the number of data point you can easily calculate this likelihood or the class conditional probability. Now by that you have to calculate this PCK given X. Okay, PCK given X means probability of class given the data point. Okay, that you have to calculate by this theorem, and this theorem is known as Bayes theorem. Okay, probability of class given the data point, this is also known as posterior probability. Okay, and how we can say that this data point is belonging to this class? What we will do, we will calculate the given a data point, we will calculate class probability of each class. Okay, and for that class, we get the maximum PCK given X. We will say that the given data point will belong to that class. Okay, so that is Bayes theorem. So this is this, and decision rule, yeah, so just we can just ignore the px, because if px is constant we can just ignore it, because we know that for each data point your px will always be constant. So we can just calculate the numerator, and if we can say if the numerator is maximum, we will get the maximum posterior probability. Okay, this is what it has been written here, so that we have to maximize only the numerator part. Okay, so if we can maximize the numerator part, we can easily say that this part is maximum. So that is regarding the Bayes theorem. Again I am repeating. We always have a prior probability or class probability. Okay, that we always have. So that is very simple to calculate. Second thing is we have this likelihood or the class conditional probability. That is also simple. Third thing is we have this px, that is the probability of each data point. That is also very easy to calculate. But what we need to calculate? We need to calculate that given a data point, we have to calculate the class or PCK given X. That we have to calculate this. So how we will calculate this? This is also known as posterior probability. Okay, so we will calculate this by the help of this theorem known as Bayes theorem. Okay, we have this, we have this, we have this, and we will just put all this and we will calculate this. Okay, we will calculate the PCK given X. Okay, and if we will then compare the PCK given X for different classes. For which class it will come maximum, we will say that the given data point will be belonging to that particular class. So this is regarding the Bayes theorem. Okay, Naive-Bayes is the same Bayes theorem, but Naive-Bayes we apply the logarithmic thing, log formula instead of this actual formula, we put the log formula. So that is Naive-Bayes. Okay, same thing, just change this formula, just put a log in this formula and you will get the Naive-Bayes algorithm. Okay, so same thing. Now these are the steps, so I will be discussing with an example. So this is a example. So you can see we have this age column, we have this income column. Age column, we have this different classes like less than equal to 30, then 31 to 40, and then greater than 40. So we have, I think, 3 classes. Yeah, we have 3 classes. Okay, now income we have 2 classes, 3 classes, high, medium and low. Student, whether it is he is a student or not, so we have this 2 classes, either no, he is not a student, or yes, he is a student. Okay, so 2 classes. Now Reddit rating, we have this fair and excellent. Again we have this 2 classes, fair and excellent. And at last that means the person will buy computer or not, so no or yes. So again we have this 2 classes. Now class, we have the C1 that is buys computer, okay, that is yes, and C2 that is not buy computer, that is no. Okay, so we have this 2 class. So this is our target thing. So we have this 2 class for this, either no or yes. That means person will buy computer or person will not buy computer. And now the question is data to be classified as X, that age belonging or less than 30, income should be medium. That means this class we have to focus, that is age less than or equal to 30, income medium, this class we have to focus. and student yes, and credit rating fair. Okay, so this all classes we should compare, and then we have to tell that whether the person will buy computer or not buy computer. Okay, so that is the exercise problem. So let's say how we will begin the question. So this is how we will begin the question. Okay, so how we will begin the question? First we have to compute the class prior. Okay, that is the most important thing, that first we have to compute the class prior or the prior probabilities. Okay, so class prior, we have this classes in the output classes are in this column. So in this column we have to compute the probability of buy computer, that is yes. So that is 1 2 3 4 5 6 7 8 9. So we will have 9 people that will buy computer. How many total we have? 1 2 3 4 5 6 7 8 9 10 11 12 13 14. We have 14 total. So 9 by 14 is your probability that is of C1 that buys computer. Okay, and probability that will not buy computer, we are left with 1 2 3 4 5. So that is 5 by 14. Okay, so we have calculated the PCI or the probability of the or the prior probability that we have computed. Now second thing, we have to compute the likelihood or likelihood. Okay, so likelihood, for calculating the likelihood is nothing x by Ci. That means data by given whether the person will buy computer or not buy computer. Okay, so that we have to calculate. Now likelihood we have to calculate for all the four column. Okay, so as it has been given in the question, we have to compute for age less than equal to 30, we have to compute for income equals to medium, and we have to calculate student equals to yes, and credit rating equals to fair. So for this four classes or for this four columns, we have to calculate the likelihood. So let's start. Okay, so let's start. So this is the first column, age is less than equal to 30, and condition is person will buy computer or not. So we have this 9 person that will buy computer, so that is why 9 at the denominator, and out of this less than 30 is 2. Okay, so you can just find out like yes. So here 31 to 40, that is not, we will take yes 31 to 40 again, less than 30. So this is one case, and less than 30, this is one case. So yes and less than 30, yes and less than 30. So that is why 2 by 9. Now probability of age less than equal to 30 and person will not buy computer. Okay, so how many we are left? We are left with 1 2 and 1 2 we are left with 1 2 and no, this. So this and this, so 3 by 5. No, we have 5 cases of no, and 3 the person will not buy computer. Okay, so that is why 3 by 5. So we got the probability age is less than equal to 30 and person will buy computer, that is buy computer or not buy computer. So we have calculated the likelihood estimate for this age column. Now similarly we will calculate likelihood estimation for this income column, this student column, and this credit rating column. So that we have calculated in this step, and then for the student column this, and this credit rating column this. Okay, so we have this 4 columns, that is why 4 likelihood estimation, 1 2 3 and 4 column, that is why 4 likelihood estimation. Now we got this x by Ci. So this was the base theorem. So first we calculate the PCI, and then we have calculated Px by Ci. Okay, and if we have this too, we can easily calculate this, because we have to just maximize this. So that is why we can ignore the denominator. We can just compute this and we will get the same thing, because Pxi is nothing, this will always remain constant. For each data point it will come 1 by 14. Okay, so that is why we can just leave this. We just calculated this and we have this. Now we can easily calculate this. So for this is the thing. Okay, this is the thing. Now we will calculate the total Pxi Ci. How we will calculate? Very easy. The person which will X and buys computer, like this and this, we will multiply together, and similarly person that will not buy computer, this and this, we will multiply together, and by this we will get the total Px by Ci. Okay, Once we get the total px by ci, we already have pci, so we can just multiply it and we can get the person probability of given probability of probability of the data point given the person will buy computer, or probability of data point given the probability of the person will not buy computer. Okay, so p cix we can easily calculate. We have this, we first calculated this, then we calculated this, and by multiple. Sorry, I got disconnected. Yeah, so this probability PCI we have calculated, Px by Ci we have calculated. Okay, so just we can multiply and we can get the PCI by x. Once we get PCI by x, we can easily compare which PCI by x is coming more. As here it has been clearly seen, this PC1 by x is coming more than PC2 by x. And what is our C1? C1 is buy computer. Okay, so that is why we can say that the person will buy computer. So that is how we solve the Bayes theorem question. Okay, so this is the thing. Second, this is the another question, you can just take a look at it. Again we have this class probability that has been given, and second we have been given this. Okay, probability px by ci is also given, and we have been told if a new item d equals to high, classify it whether it is C1 is good and C2 whether it will go to C1 or C2. So PC1, C2 we already have, and we have this PD high by C1, PD high by C2. Similarly PD low by C1, PD low by C2. So as we required this PD high by C1, what we will do, we will just multiply this PD high by C1 and PD high by C2, and then what we will do, we will just add up, and once we got this, we can compute the posterior probability. Okay, that is P C1 by D and P C2 by D. Okay, so that we can calculate, and our P C1 by D is coming 0.84, P C2 by D is coming 0.16. So clearly our answer is coming greater for this P C1 by D. So C1 is our good class, so we can easily say that this high belongs to our C1 class. Okay, so this is the complete thing. So the item is classified good with probability 84% that you can easily see. Okay, so this is the thing. So is it clear to all of you how we calculate this Bayes theorem questions? Is it clear? Clear, right? Okay, nice. So this is regarding Bayes theorem. Next we have this KNN theorem. KNN, that is K nearest neighbor. K nearest neighbor means again we will find distance, and based on the distance we will say that our given point will be closer to which point. Okay, so this is the algorithm for choose K and the distance matrix, that is we generally choose the Euclidean distance, and for each test query point x is the query point. Okay, we compute the distance, sort the training point that into K nearest neighbor. Here K is not the number of cluster. Earlier K means number of cluster. Here K means how many nearest neighbor we have to see to classify whether the data point will be belonging to which class. Okay, so this is the you can say this is the algorithm. Okay, so again you have to do this aggregate nk. Okay, so let me just explain you with the help of question. Okay, so here dataset 6 training point has been given and classes is also given. So that is the difference between classification problem and your so let me see. Yeah, classification problem and this is the difference between your classification problem and your clustering problem. Okay, so earlier in clustering problem we do not have any class. You must have seen we do not have any class in earlier clustering problem, but here as it is a classification problem, so we have this new label. Okay, so each data point now has a label with it. Okay, P1 is belonging to class A, P2 class A, P3 class A, P4 class B, P5 class B, and P6 class B. Okay, now it has been told classify the test point T3, 2. 3T, 2 is the test point, and K equals to 3. That means number of nearest neighbor here should be 3. And based on Euclidean distance, you have to calculate whether 3, 2 will be belonging to class A or class B, that you have to calculate. So for that, step 1, what you have to do, this 3, 2 is your target point, so we are terming it as T, and then you have to calculate TP1, TP2, TP3, TP4, TP5 and TP6. So we have calculated this, all this TP1, TP2, TP3, TP4, TP5 and TP6. Okay, so these are all the distances that we have calculated. Now we sort all this by the distance. Okay, so here you have to sort it by distance. So what is the smallest distance? This is the smallest distance. So we will write P3. Okay, P3 and distance. And what is the class associated with P3? So class associated with P3 is A. Okay, similarly, what is the next distance? Next distance is 2. That means P2. So P2, what is the distance coming and what is the class? And what is the next distance? 1.4142 and 2.236. So this is the next point. So your class associated with it A. Okay, similarly P4, P5 and P6. Now whenever we are choosing the voting, that we have to do with K equals to 3. So we will only consider these 3 neighbors. Okay, we will not see all the next 3 because K equals to 3 has been given. So we will be only focusing on these 3 neighbors. Now for these 3 neighbors, you can clearly see all the classes are A's. That means voting we are getting 3A and 0B in these 3 classes. So that is why we can say that this target point 3, 2 will be belonging to our A class. Okay, so that is how we do this is the step 5. This is only given only for your enhancing the knowledge. Otherwise this is the complete question. So class A we are getting 3 votes, for class B we are getting 0 votes. Okay, so that is why we can easily say that this target point will be belonging to class A. So that is how we solve our KNN problems. Okay, so is it clear to all of you? Clear, right? Nice. So that is regarding the KNN problem. Now we have this second thing, or the LDA, linear discriminant analysis from the Bayes classifier. So linear discriminant analysis is classifier you get by applying Bayes classifier under the assumption each class has a Gaussian normal class conditional probability. So this is your Px by Ck. Okay, earlier we are just calculating Px by Ck, but here we have to apply this formula. All classes share the same covariance matrix, that is this sigma. So all the classes here, this is an assumption in your LDA that all the classes will share the same covariance matrix. So sigma will be same, but you will have different means. And third thing, priors, that is P Ck equals to pi k may be different. That can be different in your Bayes also, but this is the main point, that is all the classes share the same covariance and your Px by Ck will form this Gaussian distribution. Okay, so this is the thing. Now let me again help with the quotient, that will be more easier. So this is the quotient. Classes C1 is there are 3 points in the classes C1, classes C2 have these 3 points. Pi 1 and pi 2, that is has been given. Pi 1 pi 2 equals to 0.5, and test point is this 4, 4. And you have been asked that to compute mu1 and mu2, that you can easily compute. You have this first cluster, so you can easily compute the mean of this first cluster, that is 2 plus 3 plus 2 divided by 3, that is 7 by 3. Similarly 3 plus 2, that is 6, 8 by 3. So 7 by 3, 8 by 3 is your mean for your this C1. Similarly mu2, you can calculate 6 plus 7 plus 8 divided by 3, 7 plus 8 plus 6 divided by 3. Okay, so easily you can calculate the mu1 and mu2. Now compute the common covariance, that we have to calculate, that is important. Write the discriminant function, that is an important. And fourth, classify this test point that has been given to us. Okay, so these are the 4 tasks that has been given. So LDA, for the LDA, this formula you have to remember. This formula, this is known as linear discriminant function, and this is the formula. Xt is nothing but x is your this target point. Okay, so xt is your xt is transpose of your target point. Sigma is the sigma is the this covariance matrix. Okay, and sigma to the power minus 1 means inverse of the covariance matrix. Mu k is nothing but your mean of your cluster. Okay, mu 1 means mean of cluster 1, mu 2 means mean of cluster 2. Another thing, you know, pi k is the mixing coefficient that is already given. Okay, so this we need to calculate, and we classify that whether this target point x will belong to 1 or 2 based on which del we are getting more. If we are getting del 1x more, then we will say that target point will be belonging to this class 1, otherwise class C1, otherwise we will say our target point will belong to the class C2. So we will calculate D1, we will calculate del 1 and del 2. If del 1 is coming more, then class C1, if del 2 is coming more, then class C2. That is our target. Okay. So for that, how we proceed? First we have already calculated the mean. I have already told you. First we have to calculate mean. Second we have to calculate the covariance matrix. Okay. So this is the formula of covariance matrix. Here n means the total number of data point. K means the number of cluster. K means the number of cluster here, or the not cluster, as it is a classification problem. So number of classes. Okay. So n and k is clear, and then we have to solve this. That is x minus mu k transpose. Okay, so first you have to just find out x minus mu k for all this point for C1. X minus mu k, what is x? X is this 4, 4, and what is this x is all the data points like 2, 3, 3, 3 and 4, 2, 2, that is x. And what is mu k? Mu 1 is this, so x minus mu 1 will be this 2, 3 minus your mu 1, this then 3, 3 minus your mu 1, 2, 2 minus your mu 1. That is for all the points belonging to C1. Similarly, for all the points belonging to C2, these are the points. After that, what you have to do? You have to just calculate this. Okay, this is what? This is this part, that is x minus mu k transpose. So this is your x minus mu k, and then you do the x minus mu k transpose. Okay, so this you just do for all your data points here. Similarly, this again you do, and you do all the data points for that, and then sum up all this, this. Okay, just sum up all this and then do 1 by n minus k. So 1 by n is 6, k is 2. So by this you can get your covariance matrix. So your covariance or option B is completed. After that, what you have to do? To get this, you have to calculate the inverse of the covariance matrix, or sigma to the power minus 4. So then what you do? Just calculate the inverse of your covariance matrix. After that, you have to see the compute discriminant function for both the classes, that is del 1 and del 2. Okay, del 1 and del 2. Del 1, this is the formula of del k. So del 1 means just remove k equals to 1, or just substitute k equals to 1 in this formula. You will get del 1, and del 1 is coming 25.59. Okay, here x is nothing but your target point. Okay, remember here x is your target point. Your target point is 4, 4. So that is why x is your target point. You just solve this, and you are getting del 1 is this, and del 2 you are getting 40. Okay, so it's definitely del 1 is more than del 2. So your target point 4, 4 will be belonging to class C1. Okay, so that is how we solve the LDA problem. Okay, so this is the complete thing. So is it clear how we have done it? Del 1 was coming, but what if the votes are equal for two classes? Which I think previous question you are asking, right? Previous question. Yeah. K nearest neighbor, right? K nearest neighbor. If the votes are equal for both classes, like 4 you are given, so that is why we choose K always as odd. Okay. Mostly we choose K as odd, like 3, 5, 9, 11, 7, like this. Okay. So for if we choose K as odd, then we will not have same value, like same value for each class, right? So that is why k we always choose odd in our KNN classification method. If we choose k as odd, then our that same number of voting problem will not occur. Okay, so this is the thing. So I hope it is clear now. Regarding this LDA, any question regarding LDA? Any question regarding LDA? We have to calculate del 1 and del 2. Okay. Which del 1, if del 1 is coming more, then we will say our target point will be belonging to class 1, otherwise our target point will be belonging to class 2. And to calculate del 1, del 2, two things we have to calculate. One is the mu, that is the mean of each cluster. Second is the common covariance matrix or the sigma. And for this discriminant function, we have to calculate sigma to the sigma inverse. Okay, that means inverse of the covariance matrix. So our steps would be: first we calculate mean, second we calculate covariance, third we calculate the inverse of covariance. After that we just put the discriminant function. We just calculate the discriminant function, and for which class the discriminant function is coming more, we will say that the target point will be belonging to that class. So this is regarding the LDA analysis, LDA classification. Okay, and then we are left with this Perceptron classifier. So this is the figure for Perceptron classifier. Perceptron classifier, we have this all this x1 is nothing but a data point. Okay, and this weight. Okay, weight matrix means like for each input how much weight you are giving. Okay, so that is why weight matrix. Like Perceptron algorithm, it does not consider each input will have same weightage. So each input can have different weightage. So that is why each input has been given a different weight. X1 has been given W1, X2 has been given W2, and Xn has been given Wn. Okay, so each inputs will have different weight. And then we have this W naught. W naught is also known as bias. Okay, bias. So how our algorithm stand? Our algorithm stand that Z will be calculated, Z or the output will be calculated based on this sigma Wi xi, that means W1 x1 plus W2 x2 plus W3 x3 etc plus our W naught. Okay, after that what we will do, once we get Z, we will calculate this function of Z. In Perceptron, function is nothing but the sign of Z. Sign of Z means plus or negative. Perceptron, it generally classify our data point into two groups. Okay, that is why it is known as simple linear binary classifier. That means it simple linear binary classifier. That means it classify your data point into two groups. Binary classifier means only two classes. Okay, so that is why binary classifier. Okay, so we will have all the inputs, we will have all the weight, then we will calculate this Z based on this formula, and then we will check the sign of Z. If it is coming minus, then we will say the point will be belonging to your -1 class. Otherwise, if it is coming positive sign, then we will say our point is belonging to this positive class. Okay, so this is regarding Perceptron algorithm. Now how Perceptron learns. Okay, Perceptron is basically, you can say this is the fundamental thing for your ANN or the artificial neural network, because in artificial neural network each neuron is nothing but your advanced perceptron. Okay, advanced perceptron means there the function in Perceptron you are using a simple sign function, right? But there the function could be different. So that is the only difference between your neuron in artificial neural network and your this perceptron. Okay, that is the difference. And then you have this learning algorithm. How Perceptron classify the misclassified point? How it does? It does by changing this parameter. What are the parameter? We have this weight parameter and we have this bias parameter. This Wi, all this Wi parameter, these are known as weight parameter. All this W naught parameter are known as this bias parameters. Okay, so these are the two kind of parameter we have this Perceptron. So definitely we have to change this weight parameter and this bias parameter to get to classify correctly our misclassified points. Okay, so this is the whole Perceptron algorithm. How we update the weight? We update the weight by this formula. we update the bias by this formula. And in perceptron algorithm, this is actually the interpretation of perceptron algorithm. You can easily see this is a hyperplane or line. In 2 dimension, hyperplane is known as line, but in 3 dimension, 3 dimension and above, we use the term hyperplane. Okay, same thing. So this in 2 dimension, how you separate two classes? We separate by a line, because this is a linear classifier. So we will separate two class by the help of line, and the equation of the line will be this. That is WT, or the weight transpose into your x. X is your data points. Okay, equals to 0. So this is the decision boundary. So if your answer is coming greater than this, so we have this WTX greater than 0, and we have this WTX lesser than 0. So we have this two part. In one part we will get WTX lesser than 0, and in another part we will get WTX greater than 0. Okay, so these are the two parts. And the equation of your hyperplane, or your line separating the two classes, that is WTX will be equal to 0. Okay, so this is the interpretation of your perceptron algorithm. And how we will classify the misclassified point? We will do this by updating the weights and bias, because these are the parameters. So we have to update this by this formula. So this is regarding the perceptron learning algorithm. Okay. Now let's just see this with the help of a question that will be much clear to all of you. So explain the perceptron classifier as a method of linear classification. Clearly define its mathematical formulation and iterative update. Then using the dataset provided, train a perceptron step by step for 2 iterations. Show the decision boundary after the update. Okay. So these are the two classes, class plus 1 with this 2 data point, class minus 1 with this 2 data point. Okay, and initial weights are given, w equals to 0, 0, and bias equals to 0, and learning rate is also given, eta equals to 1. Okay. Now you have to check regarding whether your points are misclassified or the correct points. If your points are misclassified, then you have to update the weights and bias. Okay, so this is the definition of perceptron algorithm. Again, I have given this, so you can just see that w is the weight vector, x is the input feature vector or your data points, and b is the bias. Okay, so this is the perceptron learning algorithm, and function is nothing but the sign of the this thing. Okay, w dot x plus b. Okay, sign will give you the y. And then algorithm step, these are the algorithm I already have discussed. So let's see the question. Okay, so we have this first point 2, 3, and the class is given plus 1. Okay, now just we will perform this w dot x plus b. How we will perform this? W is 0, 0. So we will multiply this 0, 0 with our this point 2, 3. So 0, 0 into 2, 3, w dot x plus b, right? So w dot x plus b is nothing but b is also 0. Okay, so we will perform this, and when we do this, our answer will come 0, because 0 into 2 is 0, 0 into 3 is also 0, and plus 0 is 0, of course 0. Okay, so our answer will be coming our answer is coming 0. Okay, 0 we can treat it as a misclassified point, because 0, whenever we in perceptron algorithm, whenever 0 comes, we say that it is a misclassified point, because plus 1 means our value greater than 0. Okay, 1 to infinity, that is plus 1, and 0 minus infinity to 0, that is negative. Okay, so definitely according to that concept, our point is misclassified. As our point is misclassified, we can easily do this, perform this step, that is we have to update the w and the b. How we have to update the w and b? We have to update the w and b by this formula. W will get updated by eta yi xi. Okay, so 0, 0 plus this eta is given 1, that is the learning rate, into yi xi. Yi is plus 1 and xi is this 2, 3. So our answer wi is coming 2, 3. Similarly, you can update the bias. So we have updated the weight and bias for point 1. Similarly, for point 2, when we will put this weight and bias in point 2, our answer is coming correct. So we do not have to update it. Similarly, for point 3, again it is misclassified. So again we have to update. For 0.4 again it is misclassified, again we have to update. So at the end of iteration 1, iteration means when we go through all the data points. So we have this 4 data point, we have gone through each data point, so at end of iteration 1. So at the end of iteration 1, this is our weight and this is our bias, and we can easily write the decision boundary, that is wt dot x plus b will be our decision boundary. Okay, wt not b, wt, this is the thing. Okay, wtx equal to 0. Yeah, wtx will be equal to 0. Okay, so wtx will be equal to 0, and wtx will be equal to 0. Yeah, our w is from w0 to wn. Okay, not w1 to wn, it is w0 to wn, and w0 is nothing but our bias. Okay, this is w0 is nothing but our bias, so don't forget this. Wtx means our w is from w0 to wn. Okay, so that is why we will again add the bias to it. So this is our ultimate decision boundary, that is wtx will be equal to 0. So wtx, our w is -1 into x1 and -2 plus 2 into x2. X1 and x2 are nothing but, you can also write it as x and y, but here as y means our this class has been given, so that is why it's better to write x1 and x2. So that is why I have written like this: -1 into x1 plus 2 into x2 is -1, because bias, again I have told you, bias you have to add, so bias is -1, and this is our decision boundary. X2 equals to x1 plus 1 by 2. This is our decision boundary after iteration 1. Similarly, you can do regarding the iteration 2 and see how your results are following. So that is regarding the perceptron classifier. Okay, so this is the thing. So is it clear to all of you how we have done this? Any doubt in any step, you can just ask me. No doubt, right? Okay. Okay, and then we will see the perceptron modeling of a neuron. I have told you perceptron and neuron are very much same, only the function will change. Earlier this function is a sign function, that is either it will be positive or negative. Positive, if it is positive, we will say it will belong to +1 class, otherwise we will say it will belong to -1 class. But here, instead of that sign function, we have this two function. One is signum function, another one is, we can have any type of function, but two popular function. One we have signum function, second we have this logistic or sigmoid function that we uses most often for our perceptron modeling of a neuron. Okay, so this is the only difference between your perceptron algorithm and perceptron modeling of a neuron. Other things are very much similar. So other things are very much similar, so again I am not discussing. So question is very much similar. You can see again we are updating the weights and biases. Okay, so that is why I am not discussing this. Very same. What is the difference? Again I have told you the difference is regarding the type of function. Okay, if you are given only perceptron, then your function will be function will be sign function. But as you are doing perceptron modeling of a neuron, your this active function or this here it has been this function is known as activation function. This activation function can take any function. So basically we choose this logistic sigmoid function, but that can be any function like ReLU or rectified linear unit, or this signum function is same. Signum function is same, but this logistic function is a bit different. This is a S curve. Signum function means it is a step curve, either 1 or 0, but here it is a sigmoid function. Okay, so your function can get changed, otherwise everything will remain same with the perceptron algorithm. So that is why I am not discussing it. And then we have this artificial neural network, that is very important. Okay, so it is a multi-layered feed-forward classifier. Okay, artificial neural network, it is a composition of linear maps, weighted sum plus biases, and non-linear activation function arranged in layers. For classification, we typically use a final softmax layer producing a class probability and train by minimizing cross entropy loss using backpropagation. Okay, so what does that means? That means multi-layered feed-forward neural network. So we usually have three type of layer. One is the input layer. Okay. Second, we have this hidden layer. The hidden layer can be many. Okay, not one hidden layer. It can be many hidden layer. Like hidden layer, first hidden layer, second hidden layer, third hidden layer, etc. Okay, and then we have this output layer. Input layer, it accepts the input, then all our calculation will be done inside the hidden layer, and this output layer, it will generate the output. So we have this three types of layer. Okay, and each neuron will be connected to each other. So that is regarding the classical artificial neural network. Okay, so this is the thing. Now again, each neuron will have two parts. Okay, in perceptron or in any case, each neuron has two parts. Okay, one is the sigma part, or the input of the neuron part. Okay, and second, we have this part, or the output of the neuron. Okay, so you can see here is sigma has been written here, this open space. Okay, so that is why two parts. So this is your first part, this is your second part. In first part, we have that thing wx plus b. Okay, this thing happens in first. Okay, wx plus b, that happens in first part. In second part, we have this function. Okay, second part, what will do, the function will take place. So this is only z, and this is, in the second part, we will get fz. Okay, so our fz is the output of a particular neuron. So for each neuron, like this neuron, this neuron, this neuron, this neuron, you will have this input part, and then you will have output part. Similarly, for hidden layer also, for this neurons also, you will have this input part and you will have this output part. Output layer also same. Every neuron you will have this input part where we calculate this only z, wx plus b, and then you have this output part, that is fz. Okay, so this is the thing regarding your feed forward neural network. Now, why feed forward neural network? Because the information is only going in forward direction. Okay, information is this. Okay, so information is only going in forward direction. You can easily see all the information has been going to forward direction. There is no arrow in the backward directions. That means information is flowing in the forward direction. Okay, now regarding update, because how we update the weight and bias, in this here by this theorem known as backpropagation. Why it is called backpropagation? Because error is propagated backward. Okay, information is flowing forward, but error is always propagated backward. Okay, so that is why it is known as backpropagation algorithm to train this neural network. Train means nothing but to modify your weight and bias, because weight and bias are the parameters. So to modify the weight and bias, we use this backpropagation algorithm. Okay, so this is regarding artificial neural network. Now these are all the now two things are important. One thing is the activation function. This two or three things are important. First thing is regarding the activation function. What activation function it can take? Okay, so activation function in the middle layer, we generally use this sigmoid function. In the first layer, we generally use linear function, and the third layer also we generally use either linear function or softmax function. Okay, linear function, if it is a classification problem, then we go with linear function. If it is a regression problem, we go to this regression problem, we go to this linear function. If it is a classification problem, then we use this softmax function. Okay, so this is the first thing that you should remember. Second thing is regarding the loss. Okay, how we can say that loss happens or not? Okay, so loss is calculated by nothing but, if it is a regression problem, then loss is calculated by this sum of squared error loss, and if it is a classification problem, then loss is calculated by cross entropy loss. Okay, so these are the two things you need to remember regarding classification and a regression problem. So again, classification means classification, that I have already told you, that your output will give a class. Okay, your output is nothing like 1, 2 will be belonging to B class. So your output is a class. Regression means value. Okay, so your output will be a quantitative value. That is regression. Classification means your output will be a class. In regression problem means your output will be a quantitative value. So that is regarding classification problem and a regression problem. So artificial neural network, it is first used for regression, so that is why regression is most important, and then we can use the same thing for classification. Okay, so just let me show you one question for this classification, regression. So this is regarding artificial neural network used for regression. Okay, now the loss that we use is this mean square loss or the sum of square loss. Okay, sum of square loss, that is SSE, and mean square loss means mean of all the sum of square loss. Okay, so that is MSE. And second thing is linear activation. Yeah, final layer will have this linear activation function. So these are the two things you always remember. Now for hidden layer, this is how you calculate this. I have already told you in Perceptron or any normal neural network, so that is very easy. And then this output will be given by this. Sigma is nothing but a function. Okay, sigma means sigmoid function. Okay, so that is why sigma has been written. Normally we write f of z, but here as f, we know f is a sigmoid function, so that is why sigma of z. And this is your output. Output is nothing but your linear function. Okay, so this is your output. And then this is your loss, that is important. This is your MSE loss, that is important. That is y predicted minus y actual. Okay, this hat means predicted, that means what we will calculate, and y actual means that has already been given to you. So your loss has been calculated, and what is your idea? Your idea should be to minimize the loss. How to minimize the loss? By changing the parameters. Okay, so as your loss should be minimum, that means del L by your del L by del W as well as del L by del B you have to calculate. Okay, and by that you can get your updated W and B. Okay, weights and biases. Okay, so that is how you have to solve. Now let me show you by an example, that will be better. So you can read the question like yeah, this is the question. So you can see this is your I1. You have this two input I1 and I2. Then you have this two type of weight. Yeah, this you have this is your hidden layer and this is your output layer. So two input, one output, and one hidden layer with this 3 neurons in it. Okay, so this is the thing. And terminology, I1 I2 means input 1 and input 2, O means output, and these are all the weights. V11 means the weight from this first neuron of this input layer to your first neuron of this hidden layer. Similarly 2 means like 2 means weight from second input to your first neuron of your hidden layer. Similarly you can check all this notation. And W means your weights from this hidden layer to your output layer. W11 means weight from this first output of your hidden layer to your first input of your first output, first neuron of your hidden layer to your first neuron of your output layer. 2 means first second neuron of your hidden layer to your first neuron of your output layer. 3 means third neuron of your hidden layer to your first neuron of your output layer. So this is the thing. Now for your first layer you have to use this y equals to x function. That means whatever the input, you do not need to apply anything, just you have to do this. Okay, and then this is your regarding this the neuron lying on the input layer will have this function, output hidden layer will have this activation function, and this output layer has this activation function. Okay, so there are two inputs I1 and I2 on one output O. The connecting weights I have already told you. Now these are all your weights that has been given in the form of matrix, and these are your weight from input to hidden layer that has been given by this V matrix, and this W matrix are the weights from this hidden layer to your output layer that has also been given. Now this is your data point that has been given. I1 and I2 has been given, and T0 is given, T0 is given. T0 is nothing but your actual output. But now you have to calculate the predicted output, and then you have to show the change of V, and your learning rate has been given 0.2. That you have to do. So how you will proceed? You will proceed very simple. First you will in every neuron has two parts, input and output. So input, for this input has been already given, like 0.5 and minus 0.4. So I1 and I1 and I2 has already been given. Now I01 can be calculated by this formula, y equals to x. So I1 is equal to I01, I2 will be equal to I02. Okay, so that is how you can calculate I01, I02. Okay, so that you can calculate. So you got the value of this part of this neuron and this part of this neuron. So you are done with this part. So that you have completed. Now what you have to calculate, similarly you have to calculate value of I1 and then H01, Hi2, Ho2, Hi3, Ho3. How you can calculate? Very same, very easy. You have I01 you have, and if you multiply it V11 and then you have to do this can be calculated. This is the formula. Hi1 can be calculated as I01 into V11, that is I01 into V11, and I02 into V12. These two arrows are going to this neuron, so you have to multiply this input also, this input also. Okay, so that is why I01 into V11, I02 into V21. By this you can calculate the Hi1, Hi2 and Hi3. Once you get the Hi1, Hi2 and Hi3, you have to apply this function, because this function has been given for your hidden layer. So that is why you can easily apply this function, and you can get the Ho1, Ho2 and Ho3. Similarly, you can calculate for your output function, that is OI1. What will be OI1? OI1 takes value from all these three neurons, so that is why Ho1 into W11, Ho2 into W21, Ho3 into W31. Okay, so that by, if you will add this, you can get this, and then it is OI1. Okay, again the neuron has two parts. So OI1 we have calculated, and then we will just apply this activation function, and then we will get the OI2. Okay, then we will get the OI1. Okay, so OI1 we got, and after that we have to calculate this error, that is nothing but 1 by 2, that is the total number of inputs, and then TO minus OI1 squared, and that by that we can get the error, or the MSE, that the mean squared error. Okay, that also we have calculated it. Now what we have to do, we have to change or update our parameters such that this error will get minimized. Okay, that we have to show. How we can do this? We can get the del W11 by this formula. Okay, eta del E by del W11. Okay, so you have to see where is E and where is W11. So E is somewhere here. After the output there will be error. Okay, so what we have need to do, you have need to get E to O1 and then O1 to W11. Okay, because del E by del 11 directly you cannot calculate, because in between you have this neuron. So that is why you have to get from del E by del O1 and then del O1 by del W11. Okay, so that is what has been written here. Del E by del W11 has been can be calculated by this. Del E by del O1 and del O1 by del OI1 and then del OI1 by del W11. So ultimately we have to calculate del E by del W11, but we cannot go directly because we have this neuron in between. So that is why we have to go by chain. Okay, chain rule. This is nothing but chain rule of derivation. Okay, so by this we have calculated the del O1 by del W11, and by this we can easily get the delta W11, because eta already we know, eta has been given in the question 0.02. Okay, so just we can multiply it and we can get the delta W11. Similarly, we can calculate delta W21 and delta W31. Okay, so this is regarding delta. Now delta V also we can calculate, that is del E by del V11. Again, where is V and where is E? E is here and V is here. So again we cannot directly go, we have to go from here to here, here to here, here to here, and then here to here. Okay, so that is why again we have to apply the chain rule for this. So this is the chain rule. Again, you just calculate the derivation and all that. It's very simple, and by this you can get all your updated delta V11, delta V21, V1222, and V13 and V23. Once you get all that, you can get the updated weight. Okay, because updated weight is very simple. How we can get the updated weight? That is nothing but V by or what is your original weight plus delta V. Similarly, what is your original V plus delta V? By that you can get the updated V. Okay, so this is how you can get the things. Okay, so that this is how you can perform the calculation and perform the things. Okay, so is this question clear to all of you? Any doubt? You can please ask me, no problem. Simple doubt you can ask me. At least get the steps, how we proceeded it. Any steps you can please ask me. Okay, I hope no doubt. Okay, nice. So even if you have doubt, you can please check all this slide. I will be providing it, and you can please solve the slide one by one, and you can easily understand. Okay, everything I have explained step by step, so you can easily understand it. Okay, so this is regarding the regression problem by neural network. Okay, and then we have this key differences between ANN classifier and regressor. Key differences between this two part only. Okay, so output layer, here this ANNS classifier, as I told you, we use the softmax function. Here we generally use the linear function. Okay, and this loss function here, as I just showed you, here we calculate the MSE, but here loss function we use the cross entropy loss. Okay, so this is the difference. Now evaluation of a classifier. To evaluate the classifier, we have this so-called confusion matrix. Okay, confusion matrix means we have this two things, one is actual and another one is predicted. If your like here we have this two classes, positive and negative. If your result is positive, if your actual case is positive and result is also positive, then true positive. If positive and negative, false positive, false negative, negative positive, false positive, negative negative, true negative. Okay, so how we form this matrix? So let me just show you, it will be better. So here we write actual, here we write actual A, here we write predicted. Okay, actual and predicted. Okay, now this is like positive, this is predicted. Okay, PR, this is positive, this is negative. Okay, similarly here also positive and negative. Now wherever predicted is, your positive, negative, etc. will be decided based on this. Okay, so P means predicted value is positive, means positive, positive. Okay, predicted value is negative, means negative, negative. Okay, so that is how positive and negative in your matrix come. Now actual, based on actual, whether it is true or false. So positive, positive means true. Okay, negative, negative means true. So that is why true, negative. Now negative positive means false positive. Okay, again negative positive means false negative. Okay, so that is how you form this confusion matrix. Okay, so again I can tell you the step. First you write the classes. Okay, predicted classes and true classes. Based on the predicted classes, your next thing should be like positive, negative, positive, negative. This is based on the predicted class. Here positive is there, so you can write positive, positive, negative, negative, and true or false will come from this actual. Okay, if it is positive, actually positive, and your predicted is also positive, so true. Okay, if it is negative and your predicted is also coming negative, so true negative, and otherwise it is false positive and false negative. Okay, so that is how you form the confusion matrix. Now based on this confusion matrix, you have different type of matrix. Like this is your accuracy matrix, that is true positive plus true negative, that is the accurate prediction, and divided by all your prediction. Similarly, you have something known as specificity, or it is also known as 1 minus the false positive rate, that is true negative divided by true negative plus false positive. Okay, so that is the specificity. Now you have this precision, that is very important, true positive by true positive plus false positive. Recall, it is true positive by true positive plus false negative. This recall is also known as true positive rate or the sensitivity. And then we have this F1. If we have this precision and recall, F1 score is the harmonic mean of this precision and recall, that is 2 by 1 by precision plus 1 by recall. Okay, so this is regarding the class confusion matrix. Now confusion matrix can also be formed for this multi-class problem. It is a 2-class problem, means we have this 2 classes, positive and negative. It can also be for a multi-class problem. So you can see we have this 3 classes here, W1, W2, W3, and W1, W2 and W3. So based on this also we can form the confusion matrix. Here accuracy is nothing but your based on the diagonal divided by your total. So sum of diagonal divided by total will give you the accuracy of this confusion matrix, okay, or this classification. So this is regarding evaluation of your classified, okay. So this is that. Now let me move on to the next thing, that is cross validation. Now in classification we have to provide the data, right? So we will have this training data, we will have this validation data, we will have this test data, or validation data and test data can be combined together and called as test data itself, okay. So what is this training data? Training data means you are supplying to the algorithm the data to learn it, okay. So that is training data. Test data means it is kind of unknown data that the algorithm predicts into a particular class. So that is a test data or a validation data. Again, there can be separation between your test data and validation data. Like you can think of your maths problem, right? Maths problem or your this maths textbook. In maths textbook, you first you will have all this theory. So that is training, okay. And then you will have this exercise question. So exercise question is nothing but your validation data. And then you have this example question in the text, where you will have both this question are also written and answers are also written. So that is a validation data. And then you have this exercise problem where you do not have this answer, okay. So this exercise problem or the third or the problem at the last, that are your test data. So these are the 3 types of data that we use in our supervised learning, okay. So now the problem is regarding this test data, okay. So if we have this single test data, okay, single train data and single test data, then there can be anomaly, okay, because we are just training based on a single data and we are testing based on a single data. So there can be an anomaly. For that, this cross validation term arises, okay. So idea of cross validation arises because of the problem with train and test model. It basically wants to guarantee evaluation of our model does not depend upon the way we pick the training data or test data, okay. So that is the thing. For example, like first 90% data if we pick as a training data, and last 10% data if we pick as a test data. Now based on this, it can happen that for that first training 90% training data, the training won't happen great, because that data does not have all the cases that will be tested in the test data, okay. So that is a problem. For that, we have this cross validation technique. Now cross validation can take many types, like K-fold, stratified K-fold, or leave one out. K-fold means like K equals to 10 means we will divide the data into 10-fold, okay. And then first time the first part we will take as a test data, the other 9 part we will take as a train data, okay. For the second iteration, what we will do, for the second part we will take as a test data, and other part will take as a train data. Like the 10th iteration, 10th part will take the test data, other 9 part will take the training data. So by that we are covering all the data as a training and test set, okay. So that is K-fold validation, okay. And then we have this stratified K-fold validation. K-fold validation limitation is it does not consider class, okay. Means like here when we are separating it into a particular fold, we are not taking consideration of class. So like here, when we are separating the data, for example, it can have our A class can have 60%, B class can have 40%, but when we are taking this fold, it can happen that all our classes is a class, okay. So that is a problem. So that is why we move on to the stratified K-fold. Stratified K-fold means again we will do the same K-fold, again we will do the same K-fold, but now we will ensure that whenever we are doing the fold, we will do the fold based on your actual classes. Okay, for example, if we take this fold in the stratified K classes, all the classes will be present in the same proportion in our fold. Okay, so that is stratified K fold. Last is leave one out. Leave one out means not fold, but we just pick one data point and consider all our data points as the training sample, one as the test sample, all our data point as a training sample. Okay, so that is the leave one out. So these are the three type of cross validation techniques. Okay, so this is regarding the cross validation. So any doubt in this? Okay, will we have to, sir, will we have to time to complete all this problem on time in exam? No, do not think about the problems. Problems are the problems that I have discussed. These are vast problem. Okay, that is completely for your understanding. Okay, the problem that will come in an exam will be from a particular segment of that question. Okay, for example, like LDA. LDA, I have told you, like to compute mean, then to compute covariance, then to compute the discriminant function, and then to predict the class. Now the problem that might come in the exam, that will be like only compute the mean. You will be given data point and just to compute the mean of the two centers like mu1 and mu2, or either just to compute the covariance, like this. Like one segment will come from each of the quotient I have discussed. Okay, so like this the question will come. So let's move on to the question. It will be much easier for you to understand. So topics on which week 10 assignment questions are these are the topics. So this is the first question: which of the following statement are the true for the artificial neural network? Okay, so a single neuron with two inputs and the signum function can implement AND gate. A single neuron with two input and the signum function can implement the XOR gate. Signum function is nothing but the sign function. That means it is talking about the conventional perceptron algorithm. Okay, so a single neuron with a multiple input and the signum function act as a linear discriminator in a multi-dimensional feature space for two linearly separable classes. Option D: a single neuron with a multiple inputs and the sigmoid function compute posterior of class for two class classification in a multi-dimensional feature. Okay, so this is the answer. Like, yeah, the thing is regarding single neuron or the perceptron can solve only simple gate like OR gate, AND gate. Okay, but the perceptron cannot solve XOR gate. Okay, so this is the regarding the option A and B. Okay, so perceptron are the simple neuron or the simplest neuron with signum function that can solve only simple gates. Okay, very simple gate like AND gate, OR gate, like that. Not the XOR gate. Okay, XOR gate is a complex gate, so that it cannot solve. Okay, so XOR gate is actually not linearly separable, so a single neuron cannot implement it. Okay, AND gate or OR gate is a linearly separable, so a perceptron with appropriate weight and threshold can implement it. Okay, so this gates can be separated if it is linearly separable. So you can just you can just write 0 1 and you can just perform this graphs for this gates. And XOR, you can see in XOR your you cannot separate it by a single linear boundary. Okay, so that is why this perceptron algorithm or the single neuron with signum function cannot separate your XOR gate or cannot solve your XOR gate. It can separate those gates that are linearly separable, that are simple gates like AND gate or OR gate. Okay, so this is regarding the first two option. Regarding the next two option, a single neuron with a multiple input and the signum function act as a linear discriminator, right, in a multi-dimensional feature space for two linearly separable classes. So that is very true. The perceptron with signum function separates two linearly separable classes by a hyperplane. That I have already told you, that is WTX plane. Okay, so WTX plane is a simple line because this is a 2 dimension, but whenever we are talking about more than 2 dimension, then this simple line is known as hyperplane when it is separating it. And option D, a single neuron with the multiple inputs and the sigmoid function, compute the posterior. Yeah, definitely, if it can separate it, then definitely it can calculate posterior class for a 2 class classification in a multi-dimensional feature. So this is regarding the formula of a posterior class. Okay, so that can be computed. So option A is right, option C is right, and option D is right. Option B is not right because XOR gate or XOR function is not linearly separable, so it cannot be solved by your Perceptron algorithm or a single neuron with signum function. So that is why option B is wrong. Option A, C and D are right. Okay, so this is regarding the first question. So is it clear? Is it clear? Yeah. Now regarding the second question, consider the following table. The table shows the point X and its corresponding classes. This is X and its corresponding classes. We introduce two new points, 3.7 and 4.2. Compute KNN, K equals to 3. KNN means K nearest neighbor. So K equals to 3 means 3 nearest neighbor we have to see. To determine their class, whether it is class 1 or class 2, that we have to determine for this point 3.7 and 4.2. So let's first calculate for 3.7. For 3.7 we will calculate the distance from this point, that is P1, that is 3.7 minus 2.5, that is coming 1.2. okay, and class is C1. Similarly calculate for all the points, 3.7 minus 3.25, 3.7 minus 4, 3.7 minus 5 and 3.7 minus 5.5. okay, you will get the distances. As it is a distance, so definitely just put a mod on it. Distance cannot be negative, so that is why put a mod on it. So all this distance are coming. Now from this distance, as K equals to 3, so you have to see 3 nearest point or the 3 nearest neighbors. So what are the 3 nearest neighbor? 0.2, 0.3 and 1.2. okay, so 0.3, 0.2 and 1.2. These are the three nearest distance. okay, so that is 4 point, this point and this point. These are the 3 nearest neighbor. okay, so for this 0.3 your class is coming C1. okay, 0.3 or this 4. okay, 0.3 is nothing but this one. okay, so your class is coming C1. For this 0.2, your 3.5, for 0.2 class is coming C2. okay, and for your 0.1, this 2.5, your class is coming C1. So again you will do the majority vote. Your majority vote, you class 1 got 2 vote, that is this and this. Class 1 got 2 vote, 4 and 2.5 get the vote of class 1. The class 2 get 1 vote, so your 3.7 will be belonging to class 1. okay, so 3.7 will be belonging to class 1. So either it will be B or either it will be C. Now we will check for 4.2. Very same, 4.2 when you will check, class 1 you got 1 vote, class 2 you got 2 vote. So your 4.2 will be belonging to class 2. So option B is your correct answer. okay, so this is regarding the K nearest neighbor or KNN classification. So is it clear to you? Any doubt in this question? Clear, right? Nice. So let's move on to the next question. So we have this, assume you have 5 type of object with 3 attribute, attribute 1, attribute 2, attribute 3. Consider object A as object A and object C as the initial centroid. okay, object A and object C are the initial centroid. okay, now what will be the elements in each cluster after first iteration? So it is a problem of, you can say it is a problem of k-means or k-medoid. okay, so this is a problem. So very easy, what you will say, assuming initial cluster A and C as your initial cluster, assign each object to the nearest centroid using the Euclidean distance. Okay, so again you can do this. A as your you have two cluster here because A and C are the two centroid that has been given. A and C has given, right? Yeah, two cluster has been two centroid has been given, so you have to classify it into two classes. Okay, so A and C are given, so just see whether it is nearest to A or C. Okay, now this thing distance to A and distance to C you have to see. So distance to A, distance to A, distance to C you have to just see, and then you have to do this. You have to see nearest to which attribute you have to see. Okay, so this is the thing, like 0 is coming, yeah, A for this attribute, A as your center. So for this attribute, this 1 and 4.583 nearest to A, because nearest to A, and then you have to check for all the attributes. Okay, for this attribute, B attribute 1.414 and 3.606, and this C attribute 4.583 and 0.000, because C attribute, C is your center, so that is why 4.583 and 0.000, and D attribute it is coming 4.359 and 2.449 as your C attribute, and then E attribute it is coming 2.828 and 3.000. Okay, so that is coming for E attribute. Okay, so nearest you can see nearest here, nearest is to A, nearest to A again, nearest to A, nearest to C. Okay, nearest to C, nearest to C, and nearest to A again. Okay, so that you can easily see. So this is distance to A and this is distance to C. Okay, so you can easily see what are the distance, and by that you can easily perform the clustering. Okay, so A, B and E belonging to A, B and E. Okay, A, B and E, yeah, nearest to A, B and E. Okay, so A, B and E will belonging to cluster 1, and C and D will be belonging to cluster 2. Okay, so that is how you have to do it. Okay, so A, B, E will be belonging to cluster 1, A, B, E will be belonging to cluster 1, and C, D will be belonging to cluster 2. Option A is your correct answer. Okay, so this is how you have to do it. Okay, so that is the thing, that is how you have to do it. So this is the thing, so this is the thing, so you can easily solve it. Option A is your correct answer. Okay, so this is regarding the question number 3. Okay, clear, right? Now let's move on to the question number 4. The output of a neural network 2, 4, 7, 1, 5. Find the softmax probability for 7 data point, that is this data point, answer to 4 places. So very easy, softmax function you should know. So this is the formula of the softmax function, that is e to the power xi divided by sigma e to the power xj. Okay, z belonging to 0 to 5 or 1 to 5 here. Okay, so very easy, e to the power xi you have to solve for, find the probability for 7. So e to the power 7 will be at the numerator, and at the denominator it will be e to the power 2 plus e to the power 4 plus e to the power 7 plus e to the power 1 plus e to the power 5. Okay, so when you will do it, you can just calculate it. So e to the power 7, this is your e to the power 7, and this is your e to the power 2, 1 plus 2 plus 4 plus 7 plus 5. Okay, so your answer is coming 0.8372. Okay, so 0.8372 is your answer. So again, it is a straightforward question. I hope this is clear. Clear, right? Okay, very nice. And then we will solve this. Assume you want 7 clusters, 7 observation into 7 observation you have, and you have to cluster into 3 cluster using K-means algorithm. After the first iteration, C1, C2 and C3 follow this. What will be the cluster centroid if you want to proceed for the second iteration? So very easy. Cluster centroid, if it is a K-means, cluster centroid is nothing but the mean of the data. So your first mu1 will be nothing but 2 plus 4 plus 6, that is 6 by 3, 12 by 3, that is 4. 2 plus 4 plus 6, that is 6 by 12 by 3, that is 4. So 4 comma 4 will be your mu1. Similarly, mu2 will be 0 plus 4 by 2 or 2, 4 plus 0 by 2, 2 comma 2. 2 comma 2 will be mu2. Mu3 will be 5 plus 9 by 2, that is 14 by 2, that is 7. 5 plus 9 by 2, 14 by 2 will be 7. So 7 comma 7 will be mu3. Okay. So these are the mu1, mu2 and mu3. Okay. Mu1 this, mu2 this and mu3 this. So option A will be your correct answer. Yeah, option A will be your correct answer. So I hope it is very simple. Now again you are asking me that will we have time or not. So your like K means whole iteration you won't need to do, but you would be asked simple question like what will be the mean, what will be the covariance, like this. Okay, simple question you would have asked in the question. Okay, so this is regarding the question number 5. Very simple. Now this is regarding the, I think, question number 6 and 7. Consider the following neural network, and this you have this again 2 input, you have this 2 input, you have this biases are given, bx biases. Here you will have an axis as hidden layer. This is a hidden layer with 2 neuron, H1 and H2, and then output layer you have again 2 neuron, O1 and O2, and these are all the weights, and this is the bias. Okay, bias for this layer and bias for this layer. Okay, bias for this layer is B1, bias for this layer is B2. If all the activation function are ReLU is rectified linear unit. That means ReLU is this. Okay, ReLU is this. That means whenever your Z is coming negative, your Y will be 0, and whenever your Z is coming positive, your Y will be same as Z. Okay, so that is ReLU, rectified linear unit. Okay, so that is regarding ReLU, and all the weights are also given like I1, like W11. If I consider this as V and this as W, so V11 is given -1, V12 is given -1. Similarly, V21 is given 0 and V22 is given 1. Okay, similarly you can say for W11 is given 0, W12 is given -1, W21 is given -1 and W22 is given 1. So all the weights are also given and biases are also given. Like this biases B1 is given B1 is given 0 and B2 is given 1. So all the things, I hope this is clear, and then we have to answer the question. What will be the output for the input 1, 1? So if I1 equals to 1 and I2 equals to 1 and all the activation function are ReLU, then you have to find what is the output. Okay, what is the output O1 and O2? So very simple, output you can easily calculate. So first you have to do this. I1 is this, I1 equals to 1, I2 equals to 1, B1 this, biases are there. Activation function for the hidden layer and the output layer is ReLU. Okay, output layer is ReLU, as it has been told here. Output layer means all the activation function, means hidden layer as also activation function ReLU, output layer is also activation function ReLU. Okay, so you can easily calculate the this thing, that is H1 input or H1I can be calculated by this. H1 output or H1O or H1 can be calculated by this. That is ReLU of this, because activation function is ReLU. Similarly, H2 input can be calculated and H2 output can be calculated, because this is why I am telling, because each neuron has 2 parts. One is the summation part and second is the activation part. Okay, so 2 parts. So this part is known as the input part of the neuron, this part is known as the output part of the neuron. So this has been calculated, this is nothing but the input part. Nothing, we are doing nothing but we are just multiplying and summing it. So that is this part. And for activation function, whenever we are putting activation function, so this is the output part of the neuron. So by this we have got the output part, or H1 or H1O you can say, or H1 output you can say. Similarly, you can calculate H2 input and H2 output. Okay, so that can also be calculated. Okay, and then you have to calculate this O1 again. O1 neuron also has two part. Okay, one is the sigma part and one is the function part. Okay, so again you have this, so again you can calculate the O1 in and O1 output. Okay, so again it is very easy. Okay, and this is the thing, so just calculate this, and yeah, O1 output is coming, or O1 is coming 1 and O2 is coming 1, so 1 comma 1, or option D is your answer. Option D is your answer. So I hope it is clear. Very easy. Just weight into x plus b. Okay, that is nothing but the input part, and output part is function of whatever you got, like z equals to w x plus b, and f of z will give you the output part of the neuron. Okay, so very simple. Clear, right? Okay, nice. Now in the second question, what will be the output if the sigmoid function are used in the output layer instead of the ReLU function? Here in the output layer we are using the ReLU function, but now the question has been asked in the output layer you have to put the sigmoid function. So very easy. In place of this output layer, in place of this calculation, we will just put ReLU. We will just put sigmoid. Instead of ReLU, we will put the sigmoid. Okay. Other parts are same as it is. Just in place of ReLU, we will put the sigmoid. Okay. So that is what we have done. In place of ReLU, we have put the sigmoid, and sigmoid, you know, sigmoid has this formula: 1 by 1 plus e to the power minus x. Okay, e to the power minus of x. So that is the sigmoid function. So just sigmoid function, and by this you get the different O1 and O2, because in last layer we have put this sigmoid function instead of ReLU function. Okay, so you are getting 0.731, 0.731, or option B is the answer. Okay, so I hope it is clear. Same part, just here, just let me again tell you here, previously this part summation as it is, this part we are using ReLU. This function, earlier question we are using ReLU, but here we are using the sigmoid. Earlier question we are using the ReLU. Okay, here we are using the sigmoid function. Okay, so this is the difference between your question number 6 and question number 7. Okay, so this is the, so is it clear? Clear, right? Nice. Now we are left with the rest 3 question, that is by this we will over the session. So consider a multi-layer feed-forward network, 10D feature, that means input 10 data points are there in the input, or you have 10 inputs. Okay, and produces a 2D output, that means output you will have 2 neurons. So 10 neurons in the input, 2 neuron is the output. The network has one hidden layer, you will have only one hidden layer with number of neuron 15. Okay, so 10 neuron in the input, 2 neuron in the output, 15 neuron in the hidden layer. Okay, please note that input vector in the input in the to the first hidden layer. Okay, please note that the input vector is the input to the first hidden layer. Oh yeah, so all the networks are connected, that is what has been told. What is the dimension of the parametric space over which optimization process would be carried out to train the network? That means here has been asked the number of parameter. Okay, number of parameter. What are the parameter? Weight and biases. Okay, so you have to calculate it, how many weight and biases are there, that you have to calculate. Okay, so you have this 15 neurons in your 10 neurons in your input. Okay, 15 neurons in your hidden layer, and 2 neurons in your output. So this is I, this is H, and this is O. Okay, so this is the thing. Now all the neurons are to be connected to all other neurons. So if I tell you how many weights are between this input and hidden layer, that is 10 into 15, because 10 neuron and 15 neuron here, so all are connected, so 10 into 15, so that is 150. And if I talk about number of weights from the this hidden layer to this output layer, that is 15 into 2, that is 30. So this is 10 into 15, that is 10 into 15 is how much? 10 into 15 is 150, and 15 into 2 is how much? 15 into 2 is 15 into 2 is 30. So okay, so 150 plus 30, that is 180. 180 will be weights, but now we have not considered the biases. Okay, so for each layer we will have biases. Okay, so each layer will have biases, that means we will consider this. So we will have this 15 biases here, and we will have this 2 biases here. Okay, so 15 plus 2 is 17. So 150 plus 30 plus 15 plus 2, so I think 197 will be the answer. Okay, so that is how we calculated it. Okay, so 10 into 15 plus 15 into 2, that is the number of weight, that is 180. Now for this layer, that is this input to hidden layer, we will have this 15 biases. For hidden to output layer, we will have this 2 biases. So 180 plus 15 plus 2, that is 197 will be your answer. Okay, so 197 will be your answer. So is it clear? Number of parameters clear, right? Yes. Now question number 9, this is the second last question. We want to classify whether a spatial wire is good or not. Consider the following table consisting of 4 sample: durability, strength and label. We introduce a new wire with durability 3 and strength 7. Okay, which of the following statement are true after computing kn and k equals to 3? 3,7 is a bad wire. The nearest sample to 3,7 is at a distance 4. 3,7 is a good wire. The nearest sample to 3,7 is at a distance 3. Okay, that we have to, and this is a k nearest neighbor problem with k equals to 3. So we have to see three nearest neighbor. Okay, so how we will proceed it? We will proceed it by calculating distance. Okay, calculating distance of 3,7 is our point, and we have to calculate distance with all this. Okay, that is 3 minus 7 square plus 7 minus 7 square, 3 minus 7 square, 7 minus 4 square, like this. Okay, so here the classification is bad, good and bad. Then we will see what are the nearest neighbors. Okay, 3 nearest neighbors. So we have to see what are the 3 nearest neighbors. So this is the nearest neighbor 3, this is the nearest neighbor, and this is a nearest neighbor. This we should not take, and other 3 are nearest neighbor. For this 3 nearest neighbor, the values are coming good and bad. So our 3,7 is nothing but a good wire. Okay, and nearest neighbor is nearest distance is 3, because 3 is coming. Okay, so option C as well as option D is true. Okay, option A, option B is wrong. Option C as well as option D is correct. Okay, so this is a very simple question of a KNN. Okay, so this is the. Is it clear what we have done? Very simple, right? Nice. Calculate the cosine similarity. Again, it is a cosine similarity 7482 and 32151. So it is very easy. Cosine similarity, you know the formula: A dot B, that is the dot product of this two, and divided by magnitude of this into magnitude of this. So just do the dot product in the first step, and then calculate the magnitude, and then do the answer. So your cos theta is coming 0.5842, or option A is the right answer. Okay, option A is the right answer. So is it clear? Clear, right? So by this I am ending the session, but before that let me just show you the codes, so it will be better to understand. So just on the screen, just 2 minutes, just let me show you this code. So this is the code regarding clustering. Yeah, so this is a clustering of an image using K-means, GMM, meanship and DB scan. So these two are other clustering algorithm, so you can just see. So these are the results that are coming. So this is the same photo in your same image in your this lecture notes. So this is the original image. So you can see regarding this is the original image, and this is nothing but a mushroom, and all these are dirt. Okay, so this is the K means plus boundaries. So you can see this is how it has been clustered. K means clustering plus boundaries. Okay, and this is regarding all the Silhouette's plot, that is nothing but you can say the average. Okay, average scoring. And then this is regarding the GMM clustering. This is regarding K-means clustering. This is regarding the GMM clustering. Okay, this is regarding the mean shift clustering. You can clearly see K-mean clustering is good. GMM clustering is actually more accurate than your K-means clustering. Mean shift plus clustering plus bounded, this is not so good. And then we have this DV scan. Again, DV scan is not performing that good. Okay, so this is regarding the 4 clustering algorithm and the result. You can just run this code, you can just copy the code to your drive, run this code and get the results. Okay, so this is regarding code. So again, all these codes are available in your this NPTEL CVTA folder and this CV code folder. So you can just check all this this last code for clustering, and you can just open this code and you can just play this code. Okay, so this is regarding this. And okay, so yeah, this is regarding this, and by this I am ending the session for today. We will meet on the next Friday. Okay, this Friday, not next Friday, this Friday only. And next Friday is holiday, that is why this is the extra session. Next Friday is a holiday from my side, and then we will take the class further on the next to next Friday. Okay, so next Friday, October 3rd, is a holiday, so that is why I am not taking the class, and will be taking the class on 26th, and then October 3rd there will be no class on October 3rd. Okay, so by this I am ending the session for today. We will meet in this Friday.